It's a good day. We're showing some progress here on the LAN of Things. The Pi is now serving this up as a web page, which will soon have an internal LAN domain name instead of a address. I'm still configuring things. But here we have temperatures for the last few days. Indoors red, outdoors green. Obviously, it's sort of springtime and it's swinging pretty wildly. The other two will mean more later. Right now, they're what are we saying? Basement, which is actually sitting next to my wood stove near an open window, so it's a little low. And the thermocouple cold junction, which is sitting on my bench, not too far from the other temperature, so it's going to be about the same. There's a barometer. It's inside the Pi's little box. Relative humidity, indoors, outdoors, and basement, which right now is indoors because that's where the stuff is. The water plot, which isn't interesting right now because it's not hooked up. Um, and here we have the system on chip temperature and the thermocouple, which is also downstairs, and so it's seeing sort of a normal thing, and the Pi box temperature, which is just the barometer has a temperature sensor and it's in the Pi box, so what the heck. We can change the duration of all of this and so on. Um, Depending, obviously you can't plot what isn't in the database yet. I guess the reason I have this up here, this is the CGI producing this. If for no other reason, this is to show that you can write Perl that doesn't look like line noise. A responsible programmer can come up with some fairly clean code, and this being a CGI, it's sort of hard to do in any language, but Perl makes the easy stuff easy. Awful lot of this code is just setting up GNU plot to do what I want, and it's making some PNG files that are in a directory someplace that the rest of the CGI just shows. Our index file for this is the whole file. Is not much. It's really just a link farm. Um, this program over here grabs data and stuffs it into a database that looks roughly like what I'm highlighting here. I think hopefully it's exactly like what I just highlighted. Um, and it's basically taking samples every 5 seconds of all this stuff, low passing them with a filter, first order low pass filter that is using these two constants, 0.1 and zero point 0.9, and then stuffing the database once a minute with the slightly low pass data. That gets rid of a little bit of the noise from the sensors. And yes, I use a lot of globals because GreatMind runs in the same track, and I know when I'm talking to them, so I don't step on myself. And it saves considerable time in Perl rather than passing parameters to routines that they just know. Um, so that's why we wrote it that way. But here's the thing that reads the Arduino, from a serial port, and then later on we split that up into stuff, which is, like I say, Perl makes this almost too easy. It's like one line. It's a long line. So I said, I'll complicate it a bit. And so we did some things like sum up all the water input and output rate counters over the whole minute. Duh. And if it's the first time, just jam the filter with the first sensor reading. Otherwise, do this filter thing, um, which looks like this down here, where I just multiply the input times zero point 0.1 and what already existed times zero point 0.9, sum them together and shove that back in there. And that's what we actually shove in the database. There's a lot of really horrible BMP 180 code, which I've rewritten, but it's from the original extremely horrible code. But I think the middle of this page shows the fact that if you're inexperienced Perl, you can write horrible code. I mean, that should be 2 lines. And, all these intermediate variables that only get used once, just put them on the same damn line. Come on, get over yourself. Um, Same deal with the first time we jam it, later times we filter it, and we get all kinds of cool things from files that Perl does, and so on. So this is very cool. We can go back to my home page here, And we were just looking at this plots link. The other kinds of things that Pi can do is look at my basement. I've turned on a light since I took the last picture. Or that's not my basement, that's actually my workshop downstairs, but I don't have to go there. We can, I'll stop the camera because we don't need to run it. It uses up a lot of Pi. Here's a typical picture that it took as a single picture. And just to give you an idea of how good the Pi camera is, well, we'll get it someday. I hope we get it someday. Let's try that again. Doesn't like that one, huh? Let's try a different one, which isn't all that different. It could be just that it's taking Chrome a tremendously long time to render it. These pictures are huge. In fact, let's just download one. We'll download one and then we'll go get it. So let's see, where would it be? Probably in downloads, wouldn't you think? There it is. Now, this image is considerably higher resolution than my screen, so it's pretty amazing how good this is. You know, you can even tell, you know, little scratches on things and all kinds of wonderful stuff. The Pi camera is wonderful. Now, I will be open sourcing this code as soon as this goes into production, which is going to be quite soon now. Here we go. This is eventually going to go, and we're building a new front on this building here, 24 feet long up to about the window and down to the corner and 10 feet out. And it's going to be built into a wall of that, along with moving the wood stove over there, changing the kitchen back to a kitchen and so on, so I can move over there because my fusor, which is roughly 20 feet to the left of where the picture was taken from, is too hot to be near while tuning these days, and that's really what prompted this, is as a dry run for remote controlling that and monitoring that from far enough away that I don't die from radiation exposure. I guess that's all for now. Enjoy, but this is coming right along.